Why do astronomers use angular separation for parsecs? Imagine trying to measure something so far away that even light takes years to reach us. How do scientists figure out how far distant stars are? Well, they use a clever trick involving angles and tiny shifts in position. This is where the concept of angular separation comes into play. When astronomers talk about a parsec, they are referring to a specific distance based on how we see stars shift against the background of more distant stars. A parsec is the distance at which a star would appear to move by exactly 1 arcsecond when Earth orbits the Sun. An arcsecond is a very small angle, 1/60th of an arcminute and 1/3600th of a degree. So, if a star's position appears to change by 1 arcsecond as Earth moves around the Sun, that star is exactly 1 parsec away. Using angular separation makes measuring these vast distances possible because it relies on simple geometry. Instead of trying to measure billions of miles directly, astronomers observe the tiny angle of apparent shift, called parallax, and then calculate the distance. The key formula is that the distance in parsecs equals 1 divided by the parallax angle in arcseconds. For example, if the parallax angle is 0.5 arcseconds, the star is 2 parsecs away. This method is practical because it uses observable angles rather than trying to measure enormous distances directly, which is impossible with current technology. It also provides a standard way to measure distances within our galaxy. By knowing how far stars are, scientists can map the universe more accurately and understand the scale of cosmic structures. Supporting this method is important because it underpins many other astronomical measurements and helps us build a clearer picture of the universe. So, in essence, astronomers use angular separation for parsecs because it turns a tiny, measurable angle into a meaningful distance. This approach simplifies the complex task of measuring cosmic distances and makes the vast universe a little more understandable.